All right, so there's this massive shift happening in AI, but it's probably not the one you're hearing about every day. It's not about making models bigger, it's about making them smarter in a fundamentally different way. We're talking about a move from AI that can, just win a board game to an AI that can run global shipping for a major company. So, how do we get here? Let's get into it.
And just to be clear, this isn't some science fiction demo. This is happening right now. At Maersk, the giant shipping company, a single AI is literally juggling voyages, and it's already slashed costs by a whopping 17%. That is what we're talking about when we say the second half of AI. It's a whole new ballgame compared to where we started.
Okay, so to really get a handle on where we are now, we've got to take a quick look back. Let's talk about what we'll call the first half of AI. Think of this as the era of specialists. You probably remember these headlines, right? These were the big moonshot moments for AI. In 2013, DeepMind's AI taught itself Atari from scratch. Then, in 2016, AlphaGo stunned the world by beating the best Go player. By 2018, we had AI achieving superhuman skill in a super complex video game like Dota 2, and a year later, StarCraft 2. Each one was this incredible masterpiece. But here's the thing. They were built for one and only one purpose. They were champions of their tiny digital worlds, but completely clueless about anything else. And that was the big catch. For all their power, these systems were incredibly brittle. It's like having a calculator that can do insane calculus, but can't tell you what 2 plus 2 is. AlphaGo was a genius at Go, but it couldn't play a single move of chess. And forget about asking it for shipping advice. They were the ultimate one-trick ponies, totally unable to take what they learned and apply it anywhere else. So this right here, this is the core of the story. The first half AI was specialized, it was brittle, you had to train it from scratch for every single task, and it was all about beating a benchmark. The second half is the exact opposite. We're talking about generalist AIs that are robust and can adapt. Crucially, they start with a huge amount of prior knowledge, and their goal isn't to win a game, it's to be useful. So, the big question is, how did we get from one to the other? How do you make that leap? Well, it turns out researchers basically stumbled upon a kind of recipe, a new formula for building these much more general, much more useful AI agents. And this recipe is a total game changer. It's surprisingly simple, really. Just 3 key steps. First, you don't start from scratch. You start with a big, large language model that already has a ton of knowledge about the world. We call this its priors. Step 2, and this is wild, you actually give it the ability to think as an action. It can reason and plan before it does anything. And finally, step 3, you sprinkle in a little bit of reinforcement learning, which is basically a reward system to help it fine-tune its new skills for a very specific job. Let's dig into that second step because it's so important. It's a technique called REACT, which stands for reasoning as an action. The best way to think about it is giving the AI an inner monologue. Before it makes a move, it actually generates text for itself, kind of thinking through the problem. Okay, I need to do this, but what if that happens? Then I'll do this instead. It allows the AI to plan, to handle unexpected curveballs, and to correct itself on the fly. That's what makes it so much more robust than the old AIs. And this quote from AI researcher Xunyu Yao just hits the nail on the head. He says the most important part of this whole process, it might not even be the fancy algorithm or the training environment. It might be the priors, that starting knowledge. The real magic isn't the final polish. It's the fact that you're starting with an AI that already has a kind of common sense about the world, thanks to the LLM it's built on. And you can see this exact recipe at work everywhere. Think about ChatGPT. That's an LLM that's been fine-tuned with human feedback to be a great conversationalist. Then you have things like WebGPT, an agent that uses this recipe to learn how to browse the web to find answers for you. Or even crazier, Palm Saycan, a robot that can take a vague command like, oops, I spill my drink, and use its LLM brain to figure out, okay, that means I need to find a sponge and wipe it up. They achieved an 84% success rate with this. It's the same fundamental recipe, just applied to create totally different, really useful tools. Okay, so this all sounds amazing, right? We have this new recipe, we have these powerful generalist AIs, which leads to a really interesting paradox. If this stuff is so good,
why hasn't it completely upended the world yet? I mean, this is the question on everyone's mind, isn't it? If AI is superhuman, why isn't the economy just booming? We see the headlines about AI acing the bar exam, but our day-to-day lives haven't changed that much. It's a real puzzle, and the answer points to the next big hurdle the whole field needs to clear. And let's be real, the list of what these AIs can do is just staggering. We're way past games now. They're acing standardized tests that humans struggle with, the SAT, the GRE, even the bar exam for lawyers. They're getting to elite levels in competitive programming. They're even solving problems from the International Math Olympiad. These are things we used to hold up as the absolute pinnacle of human intellect. And yet, now, don't get me wrong, we are seeing real, measurable impact. In customer support, for example, a generative AI assistant can boost productivity by about 14%. And for software developers using tools like GitHub Copilot, they're getting tasks done 55% faster. That's huge. I mean, a 55% speed up is incredible. But these are still pockets of improvement. This isn't the sweeping, economy-wide revolution you'd expect from something we're calling superhuman. And this gets us to the very heart of the paradox. Let's call it the utility problem. It's the simple fact that being really, really good at a benchmark, like acing a test, doesn't automatically translate into real-world economic value. There's a giant gap between what an AI can do in theory and what's actually useful and valuable in the messiness of the real world. So, this brings us to the final part of our story. How do we close that gap? Well, to solve this utility problem, the entire AI field is making a huge pivot. The focus is shifting away from just raw power and toward creating real, tangible economic value. You can see this really clearly in the AI startup world. The playbook is being totally rewritten. The old way? You'd come up with a novel algorithm, throw it at a benchmark, and try to get the highest score to prove your model was the best. The new playbook is completely different. It's about building a compelling product and competing on how much value, how much ROI you can deliver to a customer. The goal isn't a better model anymore. It's a better solution. And this shift is changing everything, right down to the R&D labs. Instead of just focusing on raw capability, the new focus is on reliability and safety. Because for a business to use AI, it has to be trustworthy. Instead of scaling at all costs, the focus is now on economic efficiency. Sometimes a smaller, faster, cheaper model is way more practical. And instead of just beating benchmarks, the #1 goal is solving actual user problems. Because that's where the value is, in being useful, not just getting a high score. So when you boil it all down, the game has fundamentally changed. The question isn't just, can we build it anymore? We've gotten really good at that part. The questions that matter now are, okay, but should we build it? And more importantly, does it actually help anyone? So here we are. It's a really pivotal moment. You could say the first half of AI was all about finding power. This second half, it's about finding wisdom. We have the recipe. We have the ingredients to build these incredibly powerful tools. The real question, the challenge for everyone now, is a simple one. What problems should we solve with it?